Let's take a look at example 6 from week 11. In this example, we would like to solve this slightly more difficult looking quadratic trigonometric expression here. I can see that this expression is quadratic in cosine, but I can see very inconveniently that we don't just have one squared term out front, we have 10 of them, and I can see here it doesn't seem like I can factor out 10 from everything. So based on this, I can tell that we're going to have to do some AC method factoring or some factor by grouping here. It also looks like after the fact we'll have to deal with the fact that these are really trig expressions. Now, I'm going to start with what I just said right there. I just said after the fact we're going to deal with their trig expressions. Well, what I'm going to do here to get started with this is I'm going to say, listen, there's really two whole different things going on here. One is I need to be able to understand quadratics. Two is that I need to be able to understand trig. I'd like to separate them from each other as much as possible here. And to do that, I'm going to give myself a change of variables to work with here. What I'm going to recognize for myself is that I'd really just like to think about this cosine. I don't want to think about the trig stuff here. So I'm going to create a variable that's going to sort of contain the trig information for me. Since this is quadratic in cosine, I'm going to make the variable swap here. I'm going to let, and it doesn't matter, pick any variable name you want. I'm calling it u, doesn't matter. We're just trying to make a variable swap so I can write this more simply. If u is the same thing as cosine of x, then I should be able to write this as 10u squared plus 13u minus 3 equals 0. Now what I've done is I've in a sense washed away the trig information and written this as a purely an algebra problem. Once we've solved this algebra problem, then we'll go to those solutions and we'll come back and we'll say, all right, now we actually want to get our x information back. That's when we'll come and take care of the trig at the very end out here. So for now, let's see if we can just factor this expression right here. What we learned in the last video is that to do our AC method factoring, we need to make a product pair list for A times C, which in this case is negative 30. I'm going to ask myself, what are all the ways that I could multiply two numbers to get negative 30? Well, if I'm multiplying two numbers and getting a negative, I know that one is positive and one is negative. If I'm adding those two numbers and getting positive 13, then I know that the larger of the two numbers is positive. So what do my pairs look like for 30? 1 and 30, where the larger one is positive, but the smaller is negative. 2 and 15, 3 and 10, 5 and 6. I think these are all my pairs that are associated with 30 right there. In all the cases, the larger of the two numbers is positive because my middle term is a positive value here. So now I'm asking myself the question, which of these two pairs should I choose right here? And by the way, playing these positive negative games really matters here. A very common mistake in this problem is for students to choose a pair like the 3-10 pair, because 3 and 10 make 13, but here I have a negative 3 and a positive 10. These would really add to 7 for me here. What I can see is that negative 2, positive 15, those guys will add together to give me positive 13. So I'm going to use them to rip apart my B term here. So here's what my factor by grouping steps look like. First, I'm going to rewrite this guy as, and let's see, I'll just keep it in this order, sure. Minus 2u plus 15u minus 3 equals 0. So I've rewritten 13 based on my choice of product pair. I'm now going to factor by grouping. I'm going to ask myself what's common to the first grouping. 10u squared minus 2u. Well, it looks like both of them have a 2 as a factor. Both of them have a u as a factor. If I divide out 2u from 10u squared, I'll get a 5u minus 1. In my second grouping, both have a common factor of 3. There's not a u in both, so all I can do is factor out that constant of 3, and I'm going to get a 5u minus 1 again. Remember that this is sort of your green light to go ahead on these problems right here. If we get these remaining terms in parentheses to be exactly the same, that means that you've been setting this up correctly and doing your algebra steps correctly along the way. Now I'm going to recognize that in this term and in this term, both of those terms have a common factor of 5u minus 1. So I'm going to factor out the 5u minus 1. And what I have left over is 2u plus 3. Finally, we can solve each of these equations one at a time. If I have two numbers multiplied together to make 0, then either the first number is 0 or the second number is 0. So I can set up for myself 5u minus 1 equals 0. in which case 5u equals 1 and u equals 1/5. Alternatively, I have 2u plus 3 equals 0. 2u plus 3 equals 0 gives me 2u equals -3 and u equals -3/2. So now what I have to do is decide so now what I have to do is go ahead and solve this equation. What I've done is I've found my solutions for u, but I'm not asking what value of u makes this equation true. I'm asking what value of x makes this equation true. So what I'm going to do now is, now that I've done all the algebra of this problem, I've done all the factoring and solving the algebra parts, now we need to go back into trig land and wrap up the trigonometric part of this problem. We've ignored cosine this entire time. So let's go ahead and take these two solutions here and rewrite them back in terms of x stuffs instead of in terms of u stuff. So we came up with these two solutions here, 1/5, -3/2. And what we'd like to do is determine not the u values that solve this, but the x values that solve this. Well, what I know is that u is the same thing as cosine of x. So it looks like what I really found for my two solutions here, where u equals 1/5, that's the same thing as saying cosine of x equals 1/5. Similarly, I found that u equals -3/2. Well, that's the same thing as just saying cosine of x equals -3/2. Now, part of our issue here is it doesn't look like these are any outputs that we recognize from our cosine function here. That's why in this problem I just suggested you're simply going to apply the cosine inverse function. By the way, I think in the problem statement, I think I actually said -pi/2 to +pi/2 here. This is what I really should have said. I want to tell you why I'm giving this interval though, and then I think that'll make sense. I think that when I originally wrote this problem, I had it in terms of sine instead of cosine. What I know about sine is that sine experiences all of its values from -pi/2 to +pi/2. That's why the range of the sine inverse function is -pi/2 to +pi/2. On the other hand, cosine experiences all of its values from 0 to pi. Therefore, if I use the cosine inverse function, my outputs will always be between 0 and pi. I'm looking for answers between 0 and pi, so this is sort of supposed to match the fact that you're just supposed to just state your answers in terms of a cosine inverse here. There's one last tiny technicality though before we state our answers. Here I'm asking the question, what angle results in a width of 1/5? And if I picture my unit circle here, I don't know what angle causes that, but I do know that there should be two different angles here. There's one of them, and there's one of them. And I do know that I am only interested in the one that's from 0 to pi, the top half of our circle, so it does seem like there should be some angle that will do this. I don't know what it is. I can guess. It looks like it should be kind of close to like 80 degrees or something like that. That's going to give us a cosine of 1/5. But I'm just going to simply state my answer here as x equals the cosine inverse of 1/5. I have applied the cosine inverse function to both sides of the equation, and this should be the exact answer. To get a decimal approximation, you could throw that into your calculator. Degree mode, radian mode, make sure you know what mode you're in right there. But this would be my exact answer in terms of a cosine inverse function. Very similar, let's do the same thing over here. This asks the question, what angle will result in a width of -3/2? And notice that this is -1.5. So in my unit circle, this is like saying, notice that our unit circle has radius 1, which means this width is -1, this width is +1. We're asking when do we have a width of -1.5? Well, there's no angles on my unit circle that get me that far to the left. It doesn't actually look like there's going to be any solutions for this. So I'm going to go ahead and say here, there's no solutions to this leg of our solving right here. So it looks like this is going to be our only solution. What you should do to verify this is you should go to your calculator and do cosine inverse of -3/2, and you're going to get an error. It's going to be unhappy with you because it's going to say -3/2 isn't an understandable answer. We can't look for an angle that gives us a width of -3/2 on a unit circle. The unit circle only goes from -1 to +1. The range of the cosine function is -1 to +1, so there is no such angle that will give us an output of -1.5. So our final answer for this problem we can state as just one answer, the cosine inverse of 1/5.